I'm with Dr. Gagandeep Kang, one of India's best known virologists and microbiologists with the Christian Medical College right now in Vellore in Tamil Nadu. And we are very honored to have you here, Dr. Kang, at ThePrint. Over the next 1 hour, you will be live, and viewers, please send in your questions. This is your opportunity to ask one of India's best known scientists to answer all your questions on COVID and otherwise. There's been a lot of concern, Dr. Kang, as you know, although over the last couple of days, it seems that Delhi, where I am, which was one of the epicenters of this COVID pandemic, you are in Vellore, of course, seems to be showing a little bit of a dip. So my first question to you is that, do you think that this is perhaps the beginning of the waning of the second wave, or what would you say?
I think we've discussed this previously, but a lot of control of the pandemic is in our hands and is very behavior dependent. What we've seen across the country is that in the last 3-4 weeks, there has been a lot of attention paid to the activities that will interrupt transmission of the virus, reasonable levels of lockdown, reduction of activities that lead to person transmission. And I think all of those are showing an effect. Is this over for the country? Well, obviously not. Is it over for Delhi? While you still have people who are getting infected, you are going to continue to see people coming into hospitals and sadly dying. One thing that's important to remember is that when you measure severe disease as hospitalizations or deaths, that's usually a lagging indicator. It takes a couple of weeks after the cases come down that your indicators of hospitalizations and mortality also start to decline. Mm-hmm. But looking at absolute numbers is always an error, because you need to look at the proportion of tests that's positive. And at least for that, that seems like reasonably good news that the proportion testing positive is also declining. So hopeful for Delhi, but not time to go out and celebrate yet.
Well, I think we all have to be really, really cautious about that, as you said. I mean, we declared the end of the pandemic early in January, and now we've been hit so hard by the second wave. But viewers, I would like to also say to you that in the last 1 week, the Supreme Court, no less, has ordered that a national task force be set up, and Dr. Gagandeep Kang is part of that task force. This is to do with the maintenance of medical oxygen across the country. We saw desperately how patients who were not able to get oxygen in hospitals across the country, and even today in Goa, several people, as you know, have been dying because of lack of proper oxygen. And less than 24 hours ago, the Karnataka government invited Dr. Gagandeep Kang to be part of that state's task force to look at the vaccination strategy. Now, Dr. Kang, if I could come to you about this vaccination strategy, and you, of course, have been at the forefront of developing, for example, the rotavirus against diarrhea, cholera, typhoid. So you have a lot of experience on that score. But how would a vaccination strategy for COVID, I mean, we're in the middle of it right now, what would you do with developing one, and how would you do that?
I think one of the things that's important to remember is that we are vaccinating adults, and we are vaccinating in deep scarcity of vaccines. So we need to be very clear about the goals of the vaccination strategy. Are we vaccinating to stop people from getting sick and dying? Are we vaccinating to keep society open? Are we vaccinating to get rid of the disease entirely? Once we understand what our goals are, then you can come up with a strategy and predict in what kind of time frame you are likely to be able to achieve that.
I suppose a little bit of all of those, isn't it? That you don't want to get back to normal, you don't want to eliminate the virus. I suppose it would be a little bit of all those.
when you want the perfect vaccine,
Yes.
which completely eliminates disease, completely eliminates transmission, and protects you forever, and you want to be able to vaccinate 100% of your population. Now, that's not going to happen. No vaccine is perfect. We don't have enough supply of vaccines. And we've never had a situation where we've managed to immunize the entire population.
Mm-hmm.
For example, we wiped out a disease, smallpox,
Yeah.
but we did not need to vaccinate everybody in the world to be able to do that. I don't think that it's going to be possible to wipe out SARS-CoV-2 without some very intelligent thought and a lot of vaccine and a lot of behavior change. Right now, the vaccination strategies that we are developing are very short term strategies because for the next 3 months, there is not going to be a lot of vaccine available. We've been vaccinating at an average rate of somewhere between 2 and 3 million a day. The maximum we achieved was 4 million a day. And without vaccinating at least 10 million people a day, we are not going to be achieving any of the targets that we'd set for ourselves.
So, like you said, we are running short of vaccines, and we can, talk about why we don't have enough vaccines. And I think, looking forward, say the government now says that vaccines will be available, say in a couple of months' time. Now, in that, until then, until July or August, when vaccines are available, what would you recommend that people do?
I think if you're eligible for a vaccine, you should try and get one and make sure that the slot that you have is used. Right now, it's for the over 45s, and a lot of people are hunting desperately for slots. There's a worry about vaccines running out.
Yeah.
I think the biggest thing to tell people is that we managed last year without vaccines and we came through it. The behaviors that prevented us getting infected last year still apply, and they are the most important thing for prevention of infection. What vaccines will allow us to do is actually very limited as long as there is a lot of virus circulating in the areas around us.
Okay.
You may be vaccinated, you may have received 2 doses of vaccine, but as long as there is a lot of virus circulating in your community, all of us have to continue to be careful because vaccines are not perfect. With the vaccines that we have, the Covaxin and the Covishield, shouldn't expect more than 80% protection from those vaccines, and that's against severe disease and mortality. That's not against any infection or protection against mild or moderate infection. So,
Right.
very important to remind people of that.
Okay, so the questions are coming in thick and fast, Dr. Kang. My first question from one of the viewers is that are there any harmful effects if I get a vaccine just after recovering from COVID? And viewers, I would like you to encourage you to send in your name so then I can ask these questions on your behalf. So the question, are there any harmful effects if I get a vaccine after recovering from COVID?
There are no harmful effects from getting vaccinated because our immune system is perfectly capable of handling infection and vaccination. The only question is when after infection should you get vaccinated? We know that with the data that we have from the older version of the virus, that you get at least 7 months of protection, pretty good protection, about 80%. So rather like vaccination.
Right.
With a single infection, you get 7 months of protection. So the WHO has recommended that if you've been infected, you can afford to wait at least 6 months before you get vaccinated. Now, suppose you've been infected, you've been vaccinated and then infected, then what might happen is that you'll have an overlapping immune response. If it's shortly after the vaccination, when the vaccination has not started to protect you, you'll have an overlapping immune response, no harmful effects likely to happen. but it may be a waste of either the vaccine or the infection in terms of giving you that additional boost that comes from two separated infection and vaccination opportunities.
Right. So a follow-up question from your earlier one, you said a vaccine doesn't necessarily prevent you from getting the infection, but some people have even died after getting both shots. So why is that happening?
Because vaccines are not perfect. Vaccines are good, but not perfect. So we have data from the Pfizer and the Moderna vaccines of 75 million doses being used in the US, and 75 people who had received both doses of the vaccines died. Now, that's a 1 in a million chance, but 75 people who were fully immunized died, and that's what we know. It's possible that the proportion could have been larger. The
Right.
vaccines we have in India are 80% efficacious as far as we know, which still means that people who have been fully vaccinated can get infected, can get severe disease, and can die. But the rates will be a lot less
Mhm.
among the vaccinated than among those who are unvaccinated.
Right. There's a question from Srinjoy Sarkar. He's asking, he takes a flu vaccine on an annual basis, and he has asthma. So he says, will the COVID-19 vaccine play a similar role in my life annually? Meaning, does he need to get it every year?
Srinjoy, I'm really happy that you're one of the few people who are taking an influenza vaccine every year. I think more people should be thinking about regular immunization as adults because that does prevent a lot of disease. But the flu vaccines are not very good. Flu vaccines give you about 60% protection. And the SARS-CoV-2 vaccines that we have seem to be performing much better. So, what I'm hoping for is that maybe we will need one or two booster doses of SARS-CoV-2 vaccines as the variants develop in the next couple of years, and then we won't need boosters again. Or if we need boosters, we'll need them every 3 or 5 years or so. These vaccines are really very good.
Right. Kushank Uppal has a question where he's asking, what is your stance on vaccines for pregnant women, keeping in mind that Brazil recently stopped giving the AstraZeneca to pregnant women?
Brazil based its decision on one woman who had a thromboembolic event and died after receiving the AstraZeneca vaccine. And every death that happens is a tragedy, but it is not clear whether this thromboembolic event was related to the vaccine or not.
Mhm.
We know that with the AstraZeneca vaccine, there is a risk of a rare adverse event. It's also there with the Johnson and Johnson vaccine, and this is thrombosis with thrombocytopenia, which means not only do you get the clot, but you also have a low platelet count. And this seems to be a condition that is idiosyncratic, completely unpredictable. And people who have this condition, for some reason, have developed antibodies to platelet factor 4, which is a protein that is released by platelets. And if that antibody is present, it causes your platelets to clump together and form a clot, and results, obviously, because the platelets are all being used up in forming the clot, it results in a low platelet count. Now, who's going to have that condition? We don't know. We do know that it happens in 1 in 100,000 people in Europe and about 1 in 250,000 people in the UK. There is a predilection for women, and the risks seem to be somewhat higher in younger women.
Right.
So once you're aware of the risks, you know whether you can do a benefit risk analysis that tells you whether you should use a vaccine in a particular age group or not. In India, to me, it is very clear the benefits far outweigh the risks. We've been through this before. We've seen side effects with other vaccines, and we've still gone ahead and used them because the public health need is so great. I'm firmly in favor of vaccines for pregnant women because the risk of a pregnant woman dying due to COVID-19 is much higher than the risk of her dying because of a side effect associated with a COVID-19 vaccine.
Okay. Jyoti Prakash Panda is asking, and perhaps this is in reference to the fact that you're in the Karnataka task force, is that the task force in India is recommending increasing interdose duration between the two jabs, while the UK is shortening the same to combat the surge.
So the UK is basing the shortening of the interval between the two doses on immunogenicity data that indicates that with your second dose, you get a boost. And the hope is that if you have a higher level, slightly higher level of antibodies, it's going to result in an ability to neutralize the variant that we may have exported, B1617.2.
Mhm.
Now, is this going to be a fact? I think it's when we have data, we'll be able to answer that. In India, I'm not uncomfortable with the idea that the dose is at 12 weeks right now, because I think a large part of our population has been exposed. Even before this second wave started, we had data from ICMR and from other sero surveys indicating that a much larger proportion of our population had been exposed to the virus than in the UK. So effectively, when we give the first dose in a large proportion, we are providing the second encounter with the viral protein. So then making sure that your second dose is 12 weeks later in that situation actually is going to give you potentially a very small boost in people who are seropositive. But this strategy that we're using must be accompanied by vaccine effectiveness studies so that we understand the performance of our vaccines of a single dose and the interval against various variants. We are not doing those studies right now. And if we are to make evidence based decisions, I think the need to start those studies urgently is evident to every scientist.
Now, at the beginning of this conversation, you talked about how perhaps it may be too soon to declare victory over the virus, especially in urban areas like Delhi and Mumbai. But the question is that now it seems as if tier two and three towns are being infected. In fact, Prime Minister Narendra Modi, speaking to chief ministers on Friday, did say that we have to be very, very careful in now combating the virus as it spreads across rural India. So what is happening?
Well, it's obvious. People travel and they carry the virus with them. And, viruses that have come from other places will, in this particular situation, we've had viruses that have started in big cities, mostly in international airports. They've been brought into the city and then they've spread throughout the city. And when people from the cities move into rural areas, when people from cities travel, they carry the viruses with them. And once you have viruses seeding themselves into populations in smaller towns and in villages, you're going to set up transmission cycles there. And that's what's happening. There has been a lot of travel and a lot of virus has moved with the people.
Right. Kushagra Kulshresht has a question. He's asking, given that the virus is mutating, are there any chances that these vaccines will not be effective in for a future variant of the COVID-19?
It's possible, but I hope unlikely. We already know that the new variants that we've had over the last 6 months are variants where the vaccine induced immunity is less effective than against older versions of the virus against which these vaccines were designed. And Moderna and Pfizer have already made vaccines against newer variants of the virus and are testing them in humans. So if we need to make new vaccines, we can, and we can make them quickly. However, Moderna's done a study using their same mRNA vaccine based on the older version of the virus and given that as a booster to people who participated in their early trials. So, with a fairly long gap. And what they are seeing with that booster dose is that you get a broadening of the immune response and you get better protection against the new variants as well. So we have a lot of opportunities for control. We can design new vaccines if we need them. And maybe just boosting with the old vaccines will allow our immune system to adapt to the new variants as well.
Right, lots of questions on the cross utilization of vaccines. You know, we've had right now we have the Covishield and Covaxin. The Sputnik 5 is now come into the market, and it seems as if some other foreign vaccines will also come into the near future. So, you know, the Dr. Gayatri is asking, can the Pfizer vaccine be given as a second dose after the first dose of AstraZeneca?
Okay, you can do whatever you want, but
You can
the
do whatever
data
you want. You can mix and match vaccine doses. Is that what you're saying?
is it recommended? No, but there's nothing stopping you from going out and getting any vaccine you want, and a lot of people are thinking about doing that. But I think you should apply a little science here. And you should also look at the data that has just come out from the UK, where these mix and match studies are being done. And what it shows is that you get much more reactogenicity, many more side effects, the common side effects, but many more side effects if you mix and match schedules than if you take the same one. And that is something that people really need to consider.
So I suppose, you know, with such delay in the vaccines, I suppose we will have to wait and see how that unfolds over the next few weeks. But there's another question is that if the second dose of, and this is from Prithvi, if the second dose of Covishield isn't available until the 12th week or up to the 16th week, then what happens?
Wait, it's not like your immunity falls off a cliff. If you've made an immune response, you've made an immune response. You get pretty good protection with the first dose, at least as far as we know, with even B117, which has been until B1617 came along, the most dangerous of the variants. So one dose of Covishield works against that. After that, we have data for up to 12 weeks with Covishield as a single dose used in the UK, showing again it's working really well, including in the elderly who tend to have poorer immune responses and poorer protection. And if you look at plotting trajectories, predicting based on the pattern you've seen in the first 12 weeks, what you should expect to see in the period following that, there may be a gradual waning of vaccine efficacy, but as I said, it's not going to suddenly stop once you reach 12 weeks or 16 weeks. It will wane. Wait and get your next dose. In fact, people have done studies looking at modeling immune responses, and many immunologists have said that the ideal gap between two vaccines of this kind might be 4 to 6 months. Now, obviously, even if you're going to get 10 or 20% greater protection because of that second dose, you want to try and get it in a reasonable time frame. But don't panic if you can't get the second dose. You're not unprotected.
Right. That I think answers several questions on the gap between the two doses, as well as whether you can take a different vaccines the second time around if you've taken a different one the first time around. And these are Rahul Kumar, Vishwas, Hirayur, Karianna, Prasun Goel. He has a question on vaccines for kids, but Sanjay Rai. So several of your vaccine questions have been answered. But so this question is, Shobitab Shivastava has a question on the Sputnik vaccine. She's asking whether peer-reviewed studies that are not Russian, are they available and are they sort of safe to take?
Um, so the data, so one thing is when you do a trial and you get your data into a peer-reviewed journal, the process of peer review is supposed to assess quality. But the peer reviewers who review a paper are not reviewing the raw data from that study.
Mm-hmm.
That data is submitted to the regulators. And the regulators actually go into the details of every patient that was recruited, the process that was followed, what the results are.
Mm-hmm.
And when you go from your regulator to another regulator, if you want to get the vaccine licensed somewhere else, you submit that data to the other regulator and then they review it as well. There are very few regulators in the world, like the FDA in the US, that take all of the data that is submitted to them and reanalyze it themselves. Many regulators rely on the analysis that the company does or will do some level of analysis themselves, but their focus is very much on the clinical study report as well as on what is called chemistry, manufacturing, and control that looks at the quality of the product. So the information package that we get for a vaccine safety and efficacy comes only partially from the peer-reviewed publication. It comes very largely from the regulators. And where the Sputnik vaccine is concerned, currently many regulators have looked at the data. The Brazilian regulators have raised some issues. Eastern European regulators had raised an issue previously. But what reassures me is that the WHO is currently reviewing the Sputnik vaccines package. And if the vaccine is to get an emergency use listing, that will mean that they have satisfied the World Health Organization about the data that they have submitted to WHO and to various regulators. In terms of what you asked, which is a really interesting question about independent academic evaluation of the vaccine, that comes from vaccine effectiveness studies. And to me, that's really the gold standard for how vaccines are performing in the real world. So I hope that these kinds of studies will be done and soon.
Right. A few minutes ago, Dr. Kang, you talked about how the current variant in India, the B1617, is perhaps the most infectious variant that we've seen so far. So is that the reason why, it's sort of really the ferocity of this variant that we've seen, especially in Delhi, for example, and Mumbai, of course, over the last several months? Is this particular variant responsible for that? Would you say? And is this the so-called the Indian double mutant variant? I mean, we read about all this stuff.
Well, B1617 is the double mutant, but B1617 is not one virus. There are three sublineages, and the one that seems the most infectious is B16172. And these data are coming out from India. This virus is being studied in the UK, it's being studied in the US, and we are learning more and more about the virus. Mm-hmm. But I think if we are to ascribe all of the surge to this virus, we'd be wrong. Because what we saw, at least from the limited sequencing data that was available earlier, was that in the early part of the surge, we had a lot of B117. And we've seen B1617 in many places start to outcompete B117. And in those areas, it may be responsible for driving the surge currently, but there is still a mix of viruses there. And until we are able to more closely correlate what is happening in terms of a clinical picture a geographic distribution of cases with the sequencing data, it's very hard for us to be able to explain this purely in terms of one virus.
So are many more samples now, are they being given for genome sequencing, and is the data coming out from Indian labs?
The goal was when INSACOG, the network of 10 laboratories across the country, was set up, the goal was to do 5% of all samples from all states. And states were given instructions about how to send the samples. I think there was a degree of lag in ramping up the ability to sequence. It's doing better now than it did in February. But given the surge, there is nothing like 5% being sequenced at the moment, and nor is there the kind of distribution that was initially anticipated. For many states, there's quite a lag in getting back the data from the INSACOG laboratories. These are early teething problems, and unfortunately, they are at a time when we've needed this system to be as functional as possible. I'm really hopeful that now that they've got a lot of the issues sorted out, we'll be able to have clearer answers from them in the future.
But when you say in the future, what does that mean? Is it a few weeks? Is it a few
I
months?
hope next week. Well, they are down to now being able to provide some data for as recently as April for some places. What we'd like to be able to see is weekly data from different locations in the country, particularly where the virus is surging, because that's what will be the most informative for us. 3 months ago doesn't make sense today.
Right, right. So Sanket Kulkarni has a question where he's saying, most of the infection is sort of mild or moderate. Or can you tell, how do we know what the percentage of mild and moderate infection is? How much of it is severe? And what about the chance of reinfection of variants or reinfection?
So we have a description of what proportion of infection we should expect to be mild, moderate, or severe, but we don't really have a database that tracks all patients through their clinical course. So we're still relying on data that has come from other parts of the world and publications that were based on relatively small numbers. So it would be great if we had more granular data in India. But in general, it seems like the same figures that we've seen before are operating, that about 80% of disease is mild or moderate, 15% requires medical attention, and 5% is what requires hospitalization, and a proportion of that will go on to be critical.
So would you say that between the first wave and the second wave, it seems to me anecdotally that the second wave has been far more ferocious, but in terms of data, is there any difference between the two?
If there is data that has compared the first and second wave in terms of clinical symptoms and proportions of severity, I have not yet seen it. I'm relying largely on anecdote like you are and looking at what is happening in our hospitals. I think what we are seeing is a virus that is more infectious. Is it responsible for all of the severe disease that we are seeing? We don't have an answer to that. Is the virus itself more infectious? Is it being able to cause more severe disease? I think it's possible. But again, no data to back that up. The only data that I have seen is some very limited data that indicates that the virus is replicating at a much higher level, which means that you are seeing low CT values this time around, which you did not last time.
So why is it that we don't have the data?
Good question. Um, I think data sources have been very, very limited. And I certainly, in terms of the government, there is a lot of data that is collected every time you submit a form to get a test done. I believe that data goes to ICMR, and the NCDC collects the data on hospitalization, and INSACOG has the data on the sequences. INSACOG shares, I think, with some lag to a global platform called GISAID, where the data, sequencing data are uploaded. But you need sequencing data that is annotated, that tells you about the clinical condition, that tells you about how a patient did. And that data is more with NCDC. That's not really been shared so far, and I hope that that will change. But I won't put all the blame on all these government sources. I'll also put it on us as an academic medical community, because we have been slow to build the networks that would have allowed us to collect clinical data better, that I think would have been very informative for both people managing patients and trying to predict what the future might hold, but also for infectious disease modelers that could help us predict what the future of the pandemic is.
So the infectious diseases modelers or the academic medical community and labs like INSACOG and the NCDC and other government authorities are not really talking to each other.
I can say that the academic medical researchers are trying or have tried for a very long time to talk to government authorities about access to data. And you may be aware that a bunch of us scientists had written to ask for access to that data. Our attempts so far to obtain it have not yet been successful, or if anyone has been successful, I have not yet heard about it.
But,
But
but do you
I
know
do.
why? Why are they not giving it? Do you know why?
So the answers that we are getting is that there is a process. Please submit a concept note. Tell us what you will be doing with the data. That has been done. And we are told that this will be referred to a committee, and the committee will get back in due course.
So this is ICMR is telling you this?
Not me, but other people who have asked for the data.
Okay. Some questions back on vaccines and testing, and Ajay Kumar is asking about the RT-PCR false negatives. He wants to know what percentage of false negatives exist, and sort of some approximate kind of division.
Yes, so it's been estimated that about 30% of RT-PCR tests, depending on the time of testing, may be false negatives. But I think it's also important to point out that we are in a situation in the country today where we have a lot of RT-PCR tests that are looking for a single gene of the virus, one or two genes of the virus, where as the standard recommendation has been to look for three genes.
Mm-hmm.
And if you have that kind of situation where you're looking at only one or two genes, your chances of false positivity actually go up. The quality of a test really matters, and not all RT-PCR tests are created equal.
Right. So that question was from Ajay Kumar, and Dr. Gayatri has a similar question, a follow-up on testing, where she's saying, why is ICMR pushing for the rapid antigen test when its sensitivity is so low, and perhaps won't people get lulled into a false sense of security?
So I think the stage we are at, a rapid antigen test makes some sense, because you get an answer quickly and you want to be able to act on it quickly. The second thing is that if we have a variant where the CT values are now lower, that indicates that most patients who are infected with that variant actually have much more virus. So the rapid antigen tests may be more sensitive this time around than they were in the last wave of the pandemic before this variant came around. So I don't think it's wrong to use the rapid antigen test. You should be aware of the limitations and then make sure that you interpret the data appropriately. If someone has symptoms at this time, their rapid antigen test is negative, you know that the likelihood is that it is a false negative.
Right. Some questions on protection, which vaccine is better than the other, Covishield, Covaxin, Sputnik 5. Now, Chaitanya Singh Arora seems quite troubled because he's saying no one seems to be talking about Covaxin protection. Is it a vaccine that protects us?
Covaxin has two releases of interim data. And both of those indicate almost 80% protection, one just above 80%, one just under 80%. So based on the data that have come out of the phase 3 efficacy trial, Covaxin protects. What I'd like to see now is for them to submit their entire data, which they will do to the regulators and to WHO. And then I'd like to see vaccine effectiveness studies. I think we get too hung up on these numbers,
Yeah.
because it's important to have the numbers. It's important to know that the vaccines work. But between 80% and 90%, I can't tell the difference in a phase 3 trial, because a phase 3 trial is an artificial situation. You're trying to create a situation where you see whether the vaccine works or not. So, as far as possible, you take healthy people.
Right.
You take people, you call them up, you make sure that they are doing okay, and you track their infections very quickly. So, efficacy trials are a way to know that the vaccine really works, really prevents disease, but the how much part of it depends very much on the study design. And that's why I think you testing whether the vaccine works in the real world is also important, especially when you are looking at a vaccine that generated its efficacy data in a 3-month period. You don't want a vaccine that protects you only for 3 months. You want a vaccine that's going to protect you for a lot longer.
Right.
So that information will come from real world studies.
Sure. Lots of questions on fever, people who've developed fever after the first vaccine or after the second dose, older people who haven't developed fever, younger people who have. So Shankar, for example, my 79-year-old father had no fever. I am 43 years old. I developed fever. So what is that all about?
It depends.
I mean, I'm sorry to ask you these questions, but I think people are just so nervous. Frankly, there's so many questions that are coming in, and I think there's so much fear and apprehension that it's just being transmitted to you now. I mean, I'm passing it on to you.
It's, one thing that's really important to understand is that vaccines intend to induce an immune response. So you're trying, in a sense, to do better than nature. What happens when you get infected? You get infected and you recover from that. You get sick, you recover from that infection, you get some amount of protection. In a vaccine, what are you trying to do? You're trying to make sure that you develop a predictable, strong immune response without getting sick. That's actually a little bit hard to do, because you want to balance what is called reactogenicity, the pain, the fever, the redness that happens with an injection, with the efficacy of the vaccine. So the dose is titrated to do that. Now, when you get a vaccine and you have a fever, what does that mean? That means you're responding to the antigen that you were given. Your body is making an immune response. What happens if you get the vaccine and you don't get a fever? It doesn't mean that you're not responding to the vaccine. It just means that you're the kind of person that can handle that kind of antigen without a strong inflammatory response. So it's not something to worry about if you get a fever. It's not something to worry about if you don't get a fever. The vaccines are very immunogenic and they respond. Now, I would like to address one other thing that a lot of people bring up, which is I went and got an antibody test. I took 1 dose of the vaccine. I took 2 doses of the vaccine. I have no antibodies.
Right.
It's like a disaster. Shall I now run out and get a Pfizer vaccine or some other vaccine? Well, I'm sorry to tell you this, but the antibody tests that you're getting are not measuring whether you are protected or not. We don't currently have. Why are we doing phase 3 efficacy trials? Why are we putting people through all of this, tens of thousands of people in phase 3 efficacy trials? If we had a signature that said you were protected when you made antibodies, we wouldn't need to do the phase 3 trials.
Right.
Do them because we need clinical efficacy. What does the antibody test show you? The antibody test shows you that you've been exposed to the virus in an infection or to the vaccine. And the tests that are being used by the commercial laboratories are not tests that are being used by the vaccine manufacturers to look at an immune response to their products. Those tests are much, much more sensitive than the tests that the commercial labs use, because the commercial labs are using tests that were made to say, was this person infected or not? They were not made to say, was this person vaccinated or not? When we have a correlate of protection, we can stop doing phase 3 efficacy trials. And I'll come back and tell you that there is something that will tell you you're protected.
What's that? Do you want to tell us now?
It may be neutralizing antibodies, but right now we don't have a cutoff. We need to analyze a lot of samples from people for whom the vaccine did not work to try and figure out what was missing in them that was there in people who were protected. And those are complicated studies to do, but they are being done.
Okay. So I'm going to ask you, Dr. Kang, to look into a crystal ball and tell us, when is this going to end?
It isn't.
What do you mean?
So this is a virus that is very dependent on how we do. Is it impossible to get rid of this virus? No, it's not impossible. We can get rid of this, but we'll have to do a lot to be able to do that. Is that going to happen in the short time frame? I don't think that's going to happen in the short time frame. So what's going to happen? Lots of potential scenarios. I think the most likely one is this is a virus where circulation is very dependent on environmental conditions. So we may wind up with a virus that is a lot like influenza, which has a seasonal distribution and a geographic distribution. We may wind up having 1 or 2 peaks in a year. Is it likely that the peaks will be as bad as this one? I think if we don't get a dramatically different variant, the peaks will not be as bad as this. But if you do get a variant where the behavior is completely different, effectively that will be a new virus. And then all bets are off on what the future might be.
So how do you know whether you're going to get a dramatically different variant or not?
We wait and see, and the only way to prevent that is to prevent circulation of the virus. Because if the virus is circulating among people, it has the opportunity to replicate. And when it's replicating, it has the opportunity to mutate. You're going to get a new dramatically different virus only if it continues to mutate a lot, which means it needs to multiply a lot, which means a lot of people have to get infected. Less people infected, less the chance of getting a dramatically different variant.
So from what you've seen over the last year and 3 months, how do you, how do you see, say, the next 6 months or the next 1 year unfold? And remember that we will be vaccinated, or hopefully we will be vaccinated over the next 6 months.
I am not sure that all of us will be vaccinated over the next 6 months. We will be doing our best to ramp up vaccination, but supply is going to continue to be limited. We need to get, just vaccinating one stratum of society is insufficient. We are going to need to have a reasonable level of vaccination around the country before we get to a stage where we will see much less circulation of the virus and an ability, therefore, to return to many of the activities that we were doing previously. So there is a long way for us to go yet. And I think the best that we can do is what we were supposed to have been doing all this time, which is pay attention to the things that stopped virus spread. It is masking. It is not being in crowded places. It's paying attention to ventilation, spending as much time outdoors as possible, and making sure, pay attention to hygiene and make sure that when you have the opportunity, get vaccinated.
So vaccination is the silver bullet to
No,
be able to.
it's not. Vaccination is no silver bullet for any disease because, as I said, vaccines aren't perfect. So if they were, then they could be, but they aren't. So it's not like we're going to drive this disease out of existence by just vaccination. It was possible to do that with smallpox, but smallpox was a virus that did not spread asymptomatically. This virus does. So this has to be a combination of approaches. And the bulk of those approaches beyond vaccination are behavior dependent.
So basically masking, hand sanitization, and this social distancing.
Yes, and tracking, and tracking, and tracking.
So, just a last couple of questions because we're going to run out of time very soon. Daily deaths, although the number of infections are down, deaths are still 4,000 plus a day. I mean, that's very, very worrying even now. So, what's the correlation between infection and mortality?
So, as I said, death is a lagging indicator. It happens 2 to 3 weeks after the infections. So, given that the infections we are seeing, if these are real drops in infections and not drops in testing, then death should come down a couple of weeks after the number of cases started coming down.
Mm-hmm. Are you still talking about herd immunity, or is that phrase something that you threw out a long time ago?
So I think herd immunity is still possible with sufficient levels of protection in populations, but herd immunity depends on a lack of introduction of new infectious agents as well. So we definitely, it's something that is achievable with high levels of vaccination and being able to look at limiting entry of new infections into the herd. What's going to happen? If you can drive disease down to manageable numbers, as I said, with testing and tracking, you have the opportunity for isolation, for making sure that there is a quarantine system that does not allow an infectious person to enter into a place where you have managed to control the disease.
Mm-hmm.
So lots of challenges ahead, but nothing that is impossible.
Right. And so, in a sense that, if India is 1.4 billion or 1.3 billion population, what percentage should be vaccinated for you to, or for India to achieve herd immunity, assuming everything else is also being done?
With more infectious viruses, the proportion of the population that needs to be infected or vaccinated goes up. So, for example, for measles, which is much, much more infectious than any of the variants that we have for SARS-CoV-2, we've estimated that you need over 95% of the population to be vaccinated to have some level of herd protection. With SARS-CoV-2, there were estimates anywhere from 20 to 60% last year. I think people are thinking more like you need about 3/4 or 80% of the population to be protected by infection or vaccination now.
There's a question on, again, Covishield and the B1617 variant. Is one vaccine better than another? I mean, not that we have much option, we take what we get, basically.
Yeah. So the data that came out from the National Institute of Virology shows that there is an approximately 50% reduction in the ability of people who have been vaccinated by both vaccines to neutralize B1617. That is usually, usually you make much more neutralizing antibody than you need. So there should be protection against this particular variant with both vaccines. The question to me is, how long will the protection last? Currently, we don't know that for any vaccine and for any variant because we've had the vaccines for a very short time. But as I mentioned previously, it's not like you wake up one morning and all your protection is gone. It's a slow decline. And the more we track who's getting infected and what their vaccination history is, the sooner we will have answers about what is protecting against what virus and for how long.
So the chances of mutant strains that escape the vaccine, I mean, I don't know whether this question makes sense or not.
Yeah, so, every mutant strain that is considered an immune escape variant is trying to escape the vaccine. And in the laboratory, it has been determined that if you keep up antibody pressure against the virus, you can generate these immune escape variants. The question for us is, how do we do the best we can to make sure that there are as few immune escape variants as possible? And we do that by making sure that there isn't that much virus out there. The less virus there is, the fewer people that are infected, the less the chance for this virus to make immune escape variants. There was a rather illogical, shall we say, letter that was being circulated by somebody who was called a vaccine scientist who had previously worked for vaccine companies and for Gavi, coming up with an immunological argument saying that vaccinating during a pandemic would create more immune escape variants. We don't have the time to go into an explanation of all of that as yet, but the facts are wrong. His illustrations are wrong. And I'd love to have more time to explain why I think what he's saying is hogwash.
Okay, so that question on the escape variant was by Dr. Tahir. And my last question to you is what have we learned over the last 1 year, over these last two waves? Is one of them perhaps, I remember early on we were, wiping surfaces. Now, is it that this wave or this variant is sort of more airborne? I mean, we read a lot about airborne transmission.
I think what has changed is our understanding of the sizes of particles that are put out by viruses. And our previous description from WHO and others was droplet infection, which is particles that are 5 microns in size or larger. And then you had aerosol, which was 5 microns and less. Now, that kind of arbitrary distinction actually doesn't make a lot of sense. Much of what we do, whether it's talking, singing, or the so-called aerosol generating procedures, all produce particles of varying sizes. The aerosol generating procedures generate a lot of smaller particles, and the other things that we do talking generates more larger particles. But there isn't a hard and fast cutoff at 5 microns. So, yes, you still will have a virus that lands around you, so requiring the hygiene, as well as virus that floats around for a while. And that speaks to the importance of the quality of the masks that you use, because it is N95 masks that cut transmission much, much more than masks that are surgical masks or cloth masks. I've actually been pretty worried about some of the masks that I see on the road, not only about how they're being used, but the quality of the mask, where you can tell it isn't really stopping anything.
Right, because it's just basically a piece of cloth that's covering your face and your nose.
Not much use.
And you see a lot of, especially even though there is a lockdown in Delhi, for example, a lot of people, the couriers, and everybody's wearing these cloth masks. So you're saying those are completely ineffective.
Not completely. Cloth masks give you some level of protection. Surgical masks are better than that. N95 masks are the best. Surgical masks are estimated at about 55%. So, and cloth mask depends on the mask, but may be as bad as 20% or as good as 45%.
Cloth masks are as bad as 20%, meaning.
Depends on the weave, the number of layers.
Right. So I suppose in a country like ours, where the N95 still costs 100 rupees, and the surgical masks, of course, are much cheaper, 5 or 10 rupees, and I suppose that's one factor in protecting ourselves. But Dr. Kang, I'm really grateful to you for your time, for speaking to ThePrint, for taking so many questions from the viewers of ThePrint. I really appreciate this, that you've spent a whole hour with us. Thank you again for your time. And viewers, thank you so much for logging in and for asking all your questions to Dr. Kang. Thank you.